So the first of these solution algorithms we're going to start with is example 6.1, just to really start at the very top and work our way down. This is on the bottom of page 73. Just to go through the problem here quickly, we're designing an algorithm that will prompt the user and receive pairs of numbers from the operator at a terminal and display their sum, product, and average on the screen. So this is something you've done already with the pseudocode 1. You have taken numbers from the user and you have given their sum, product, and average. If the calculated sum is over 200, an asterisk will be displayed beside the sum. So already the difference here is we know that we are going to need some kind of selection, an if statement if you prefer, and it's really easy to see that that's going to happen because right here we literally have an if in the sentence, which is there to help kind of point you at the fact that we're going to need a selection. The program is to terminate when a pair of 0 values is entered. So just to highlight this really quickly, the pair of 0 values, that's a terrible pen color, is entered. So that is going to serve as our sentinel, right? So 0, 0 is going to break us out of that loop, right? So that's already letting us know that there are constraints to the way it is that we are going to design our algorithm. So things we know we're going to need. So if we had a defining diagram or our IPO chart, right? We would have IPO for input, process, and output. We know we are going to get two numbers, so num1 and num2. Processes, we know we are going to need the sum, product, and average. That's just to help reduce the amount of terrible handwriting you have to be subjected to. And our outputs are going to be sum, product, and average again. So this is essentially everything we would need in the defining diagram or the IPO chart. You'll notice we don't have really robust examples of what our process outputs are going to be. We're not including, what do we mean by average here or things of that nature. Really, this is here to serve as a checklist for us to make sure that we have accomplished everything that we need to accomplish without one of these glaring omissions before we try to actually deploy our solution algorithms. And if we scroll down, I just want to kind of highlight a couple of the things that are happening here inside of, and I should get a better pen color, here inside of the actual solution algorithm. And this is here on the bottom of 7.4. A couple of things to notice. You'll notice that we have a set sum to 0 here at the very top, right? Because sum is going to be something that we will consistently throw more new values into. And as I'd mentioned in a previous screencast, in real compile time languages, there's little assurance that the storage space that we had given to sum previously hadn't already been assigned or given a value by some other process. So these instantiators, right? So we want an instance of sum here, and we want to give it a set value. So that's important to us. It's nothing that is particularly easy, honestly, to show in pseudocode because you're the compiler, I'm the compiler. But it's good practice and habit to get into. So again, we have kind of the baseline, not good enough, but we understand what they're trying to tell us by prompt for number 1 and number 2 and get number 1 and number 2. Now we've got our looping structure here. The design of the loop is a do while not number 1 and number 2 equal to 0 is essentially happening inside of there. Could we do a repeat until? No. So a repeat until would have down here at the bottom of the loop, that's where the decision would be made. So what would happen if on our very first time through, number 1 is 0 and number 2 is 0? That's not going to be good for us, because when we're trying to go through and get the product, the sum, and everything else, we're going to have divide by 0 potentially. Actually, if we had the product, we do have the product in there, that's what that's going to do. So we don't necessarily want that, right? We want our decision to be here at the very top of the loop. So next we go through and we do our math, right? So now we know that if the sum was over 200, and that's what's happening here with this line, if sum is greater than 200, and we just want to display an asterisk next to the sum, and that's everything. Otherwise, else, if sum is not greater than 200, display everything without the asterisk there. One thing to note here, could we do this with a null else? No, we could not, because if we just had an if statement without, I'm going to cross that out, without the else there, we would get nothing to display if the sum was less than 200, which is certainly not what we want to have happen there. And then we've got one transaction completed, right? We have taken a set of numbers from the user. We have gotten their sum, product, and average. We have determined if that sum is over 200, and we have made a display in one case or another. So then you'll notice we have here inside of our loop, right? So the end do is down here. So this next portion is inside of our loop. We have to prompt again for number 1 and number 2 and get number 1 and number 2. This time, if I, so number 1 equals 0, number 2 equals 0, when this goes back up here to the top of my loop control structure to evaluate, this time around, number 1 is 0 and number 2 is 0, and that means we do not enter here in through our loop, and away we go, and we're done with the program. So here we have a mixture of sequence, selection, and repetition in order to get the job we need done.